Let's see the first question in exercise 4.3. Here we have been given three quadratic equations and we have been asked what is the nature of the roots. So let's begin with the first question. This quadratic equation is already in the form ax square plus bx plus c equal to 0. So comparing the coefficients, we'll get a equal to 2, b equal to -3, and c will be 5. A is the coefficient of x square, b is the coefficient of x, and c is the constant term. When we are evaluating the nature of roots, we will try to calculate the parameter b square minus 4ac. This is also called discriminant, symbolically denoted by delta. This is the term which is under square root in quadratic equation. And this is, if you notice it, we will see that in a minute, it is always plus or minus. So this is responsible for giving two distinct terms. So the nature of the root is primarily decided by what is the value you get b square minus 4ac. Let's substitute that one. -3 square will come out to be 9. And 4 times 2 times 5 will be 40. So this will come out to be -31. Now, depending upon the value of b square minus 4ac, if it comes out a negative like this one, you will get imaginary roots. If it comes out to be positive, then you'll get real and distinct roots. And if it comes out to be 0, then you'll get real but repeated or same roots. So there are three possibilities, and b square minus 4ac, whether it is greater than 0, equal to 0, or less than 0, we have three possibilities. Luckily, all three are eventually covered in this particular exercise, and we will see all three possibilities. So the first possibility is if it is negative, then the discriminant is negative, so you will get roots that those will be imaginary. Let us see the second sub question, 3x square minus 4 root 3x plus 4 equal to 0. Again, we will compare the value with a, b, c, get those coefficients. A will be 3, b will be minus 4 root 3, and c will be constant term positive 4. Here, the delta will be b square minus 4ac. Again, we'll try to substitute and evaluate them. Negative square will be still positive, 4 square will be 16, and root 3 square will be just 3. So it's 16 times 3, that will be 48. So once you evaluate this bracket, it will come out to be 48. Now here, 4 times 3 is 60, 4 times 3 is 12, times 4, that will be 48. 48 minus 48 will be 0. Now this covers the second case. If the discriminant b square minus 4ac comes out to be 0, then the roots are real but equal. So it's the same root repeated twice. Now in the question they have said, if the real root exists, then find them. In the first sub question, since the roots were imaginary, we stopped right there, we did not proceed. But here the roots are real, so we have to actually find them according to the question. The quadratic expression is given with this particular formula. Notice that it is the b square minus 4ac, which is the part under square root, that is associated with plus or minus symbol. So it's this part which is responsible for giving two different values for the roots. If this comes out to be negative, well, we cannot evaluate the square root of negative number, and then it becomes automatically imaginary. What if this is 0, which is happening in this case right now? If this is 0, then square root of 0 is 0, and then there is nothing to do plus or minus. So because of that, we get the same root twice. And this is what will happen. Let us substitute the value. Negative of -4 root 3 will become 4 root 3. And divided by 2 times 3, we can cancel 2 and 4. The final answer will come out to be 2 root 3 divided by 3. So it's the same root we are getting twice. And some people will cancel this root 3 and 3 and put root 3 in the denominator. It's not really required because we prefer rational number in the denominator, and this is already in the rationalized form, so no need to further cancel. So this will be your final answer for second sub question. Let us see the third part, 2x square minus 6x plus 3. Here also we'll do the same thing. First get the coefficient and plug them in discriminant expression, which is b square minus 4ac. And once you substitute that, minus 6 square will come out to be 36. 4 times 2 is 8, times 3 is 24. So the discriminant delta will come out to be 12. This value came out to be greater than 0. So we will get not only the real roots, but this time we will get different roots because there will be something to add, subtract, plus or minus. Let's see. Again, apply the quadratic equation and now substitute the value. B square minus 4ac is already evaluated, that's 12, and minus minus will become positive, so this is 6. And since 12 is not a perfect square, well, we can leave it as it is, that's one way, but let's try to extract as much, let's try to simplify as much as we can. 12 can be split as 4 times 3. Here 4 is a perfect square, so that can be taken square root. So it will become 2 because it came out of the square root, but 3 remain as the under square root. So this will become 2 root 3. So 6 plus or minus 2 root 3. Now if you notice that there is a 2 factor which is common throughout the expression. So let us divide everything by 2. So this will become 3 plus or minus root 3 divided by 2. And that will be your final answer. So the nature of the root is primarily decided by discriminant, which is b square minus 4ac. If it is less than 0, we will get imaginary root. Right there, stop. No need to proceed further. If you get 0, then you get same root repeated twice. And if you get discriminant greater than 0, then because of this plus or minus something, you get 2 separate roots. So what are those 2 roots here? One is 3 plus root 3 divided by 2, that's 1 root. And second root is 3 minus root 3 divided by 2, that will be second root. So we got 2 separate but real roots, and that will be your final answer for the third part.